developer of solutions and applications for mobility, and recently a WiMAX. Thank you.
Okay, thanks, Nacho. In addition to my role as with NextWave Wireless, I have another hat that I wear, which is chair of the IEEE 802.16 working group that develops the standards that underline the WiMAX technology. So you'll see as I give my talk that a lot of my viewpoint is colored by that basis, and you should know from advance that's where I'm coming from. And I wanted to first take a look at where we're going in this meeting at kind of a high level, taking a look at the title and trying to understand what the title means. And I see the title coming in two pieces, the open mobile networks part and the new opportunities from outside telecom part. We're asked to talk about trends, and I like the fact that the title was chosen that with terms that really I see as trends. And open mobile networks is a trend. That trend is allowing more innovators innovate. Let them use the network and build innovations on top of it. As far as new opportunities from outside telecom, I think what we've heard a lot of so far is the idea of telecom players partnering with other organizations to move things forward. And I think that's part of that. And I think the other part of that issue is new service providers that are coming outside of the legacy wireless community who want to come online and provide some alternative or competitive offerings. Some big delay here. I push the button and then I wait. Then I wonder if I should push it again. And I'll get 2 clicks. So another key trend that I'd like to mention is what I call 4G mobile networks. There are various definitions of 4G, and you've heard them before. But from my perspective, the first of the 4G networks is the ones based on the IEEE 802.16 and the WiMAX technologies. They're going to be followed behind by some other ones, particularly what's coming out of the 3G community. But I'll talk a little bit in a couple of slides from here about what makes up these new 4G networks, but they are being led. They're rolling out now with deployments in Korea. Taiwan is very advanced, Japan, the US and India, some other marketplaces where they're starting to become available. My perspective is that the 2G and 3G communities are not ready for this yet. So they see 4G as the long-term evolution for their community. That's why they came up with this term LTE to describe this 4G from their perspective, because a lot of these guys, I think you've seen a lot of the big players in even the 3G world have something like less than 10% of their users on the 3G systems. They're not ready to invest in another system yet. But the new players who want to come in are going to bypass recreating that whole legacy telecom environment and move straight into the 4G technology. So I thought about this open mobile networks as a topic, and I just wanted to put down some ideas about what that might mean to me or to some other people. One thing is that I think that you can talk about the basis of the network as being based on open interoperability standards. That has lots of implications, and if you want to understand the different definitions and implications of openness, I put a couple of references on here, one to a nice paper by Ken Kretschmer, and another to a recent set of recent declaration that I learned about from David Eisenberg's blog.
And I learned about it, by the way, from Michael Silo.
Okay, so good. So we've got some synergies here. Another issue that's really separate is the idea of openness of the network to terminal devices that may be not necessarily the ones that are promoted that you buy from the company store of the company that provides the telecom systems. Are they available and are they attachable? Then you have issues of openness to higher layer applications with different technical requirements that run over the network, and you can talk about, in addition to that, openness to application providers in terms of different companies that may be providing applications on top of your network. And this slide talks about the specific issue of the interoperability standards, and I'm going to use the IEEE 802.16 standard that I'm familiar with as the example of that. It breaks ground as a 4G standard from a few of the fundamental assumptions that it brings into place. It's a layer 1 and layer 2 standard. It comes out of the same background as the other IEEE 802 standards. Some of the successful ones there are Ethernet and 802.11 Wi-Fi and actually quite a few others and some personal area networks. The physical layer technology is OFDMA, and it uses MIMO, which is multiple antennas. It helps bring in a lot of higher capacity. And this is what all the 4G standards are using. The layer 2, it's a scheduled system that's QoS oriented to provide a mix of multimedia services and do it all over the same network. I think that's what everybody's going to also. The orientation is interesting because in IEEE 802 there's a requirement that you not specify anything above layer 2. And that means that you have to be able to fit this on anybody's network. Now that gives you an exposed open interface and is a very nice opportunity to try to use this on multiple networks. And that's one of the things that makes 802 successful. But the orientation is to generic packet-based networks, IPv4 or IPv6, and that makes it very easy for new providers to get into this business because all you need is basic IP connectivity, and you can start installing a WiMAX base station. This has been evolving in IEEE since the 90s. It's a very well-represented group, by the way. In 802.16, we have 433 members. I just did a count of 16 countries. We meet every 2 months, and we have 400 to 500 people coming to meetings. Another slide I put together talks about openness to user devices, and I think there are different ways to look at that. But I think that, in general, what you're seeing is a trend toward a whole variety of users and different kinds of terminals. So it could be traditional terminals like laptop PCs or mobile internet devices. Also interface devices, which it's not a whole terminal by itself, but it's an interface to a terminal. So it could be a USB card or a PC card, even a Wi-Fi interface so that you can interface your existing devices onto a gadget that then can connect to the wireless network, the large scale. A lot of non-traditional devices like cameras, video cameras, personal media players. Basically, the openness means that innovators are free to innovate and come up with terminals that are going to be productive on the network. And in general, people are going to want to buy those from the marketplace, not necessarily subsidized devices that are provided in the company store, but things that you acquire any way that you want. I put on the corner here a little card that I think is very cool. It's something called the iFi that's made for Wi-Fi, and it's an SD memory card that goes into a camera, has built-in Wi-Fi, and it does location tracking. So when you take photos on your camera, whatever your camera might be, this thing will find a Wi-Fi access point when it can, either while you're taking the pictures or sometime afterwards. Transfer your photos up, including geographical information for you, and make them available for other uses. This is a very innovative idea that I don't know anybody that would have thought of, and certainly an operator would never have thought of this thing. But because Wi-Fi has a cleanly defined interface with a protocol for conformance test, somebody knows that that device is going to work. It's going to work on the Wi-Fi system, and you can provide this thing. It's going to work on anybody's access point. The same thing is happening with WiMAX. The really focus of the WiMAX forum is to develop certification and interoperability testing to certify devices will meet and will function properly over that radio interface. It's a very, very big effort. It take a long time, and that's the reason it's taking a while for the 802.16 mobile standard, which was completed a few years ago, to actually make it to the marketplace. The tests are, the certifications are actually underway at the moment, and the initial product testing has been announced. I want to talk about QoS, quality of service, particularly in relation to the talk that David gave, and he talked about capacity and scarceness. From my perspective, there is a real scarceness at the radio level. Now, it'd be great if, to the extent that technology can come up with, apply some of the solutions we have to try to get more out of the radio spectrum, that's going to be fine. For the moment, though, a lot of operators are assigned certain spectrum bands and they have to work within regulations. And in that circumstance, a functional network is going to be working at capacity. If it's not working at capacity, if you're not using all that spectrum, there's something wrong, and there's something really unfortunate in the way your spectrum's been allocated and the way you've used it. So the network operator has, from my perspective, has a responsibility to optimize the network resources. And the uses are inherently differentiated. Not all the services on the network have the same requirements. There's all kinds of multimedia services, whether you're talking about voice or video services, gaming, video conferencing, and different users have different requirements. The QoS in a network lets you differentiate the network in order to account for the different users. And I think that there's an opportunity to actually use economics to do the discrimination. You don't have to necessarily, people look traditionally at some very brute force tools to allocate spectrum economically, and they'll say, well, there's a fixed rate plan or a flat rate plan or we're going to count the bits plan. But with QoS, you have all kinds of ways to do that on much more sophisticated levels in terms of prioritization, and users that require higher priority can get it. But if nobody else is using the network and somebody wants to transfer a video, there's no reason the operator ought to care if that's the only person that needs it at a certain time. I think that those kind of tools can give you a more efficient use of the network. And that doesn't mean that there are reasons to favor one provider or another. I don't see any technical justification for that. The cellular industry, the phone industry is in transition, and when the PC responds, you'll see the picture that I put together to go along with this, essentially transforming in a lot of the developed countries to a situation where you're looking for mobile services that may be multimedia intensive, lots of video, lots of requirements for spectrum to be moved. I've got one slide here that represents what my company, one specific aspect of what my company is doing, that just trying to illustrate this innovativeness. We've introduced this reference design for a personal media player that uses the WiMAX chipsets that we're making. And all this, what this is doing is taking advantage of the fact that the OFDMA that's used by WiMAX and these other technologies is very, very flexible, and you can actually allocate part of your spectrum to something like a broadcast video service while you use the rest of your spectrum to do something more traditional two-way. And this would allow you to do a broadcast video solution that runs over the same network that's doing a two-way system. And this is the intelligence at the end of the network that David is talking about, and lets innovations happen if the network is very generic. So in conclusion, the new open 4G standards provided the tools for innovative operators to create innovative and open wireless networks that are open to innovative services. Okay, thank you.
Thank you.